Hi everyone, in today's video, let us know how to check and replace electrical components of refrigerator. Objectives: at the end of this video, you can be able to: Number 1. Check and test the current coil relay. Number 2. Check and test the overload protector. Number 3. Identification of compressor winding. Number 4. Check the short circuit in the compressor. Number 5. Check the condition of a door switch. Number 6. Check the thermostat and the capacitor.
Let us collect the tools and materials required to do this practical. Screwdriver 10 mm tip, 200 mm length, 1 number. Cutting plier 200 mm length, 1 number, insulated. Nose plier 1 number. Phillips screwdriver set 1 number. Ohm meter or multimeter 1 number. Test board fitted with voltmeter and ammeter 1 number. Refrigeration all electrical components direct methods 1 number. Current coil relay 1 number. OLP overload protector 1 number. 2 meter 1 square millimeter lead wire as required. 2 meter wire with crocodile clip as required. Thermostat 1 number. Capacitor 1 number. Line tester 1 number. Test lamp 1 number. Insulation tape 1 number. Thermal fuse. Timer with motor terminal pin fan motor. Defrost heater. Fan motor. The measure. Procedure. Task 1. Test the current coil relay. Step 1. Check continuity between 4 and 5 with the help of ohm meter. Step 2. If the continuity is okay between 1 and 2, coil continuity of current coil relay is okay. Normal condition 4 and 5 continuing will be there. Step 3. Check continuity between 5 and 6. Normal condition when not in use. 5 and 6 open. If there is no continuity between 5 and 6, relay is okay. Step 4. Keep the relay upside down. Check continuity between 5 and 6. If the continuity is there, relay is okay. Step 5. Bring to its original position. Check continuity between 2 and 3. If there is no continuity, relay found okay. Step 6. Check plunger movement and observe sound. Keep the relay upside down. Plunger moves up and you can hear the sound. Bring to normal position. Plunger comes down. You can hear sound. If there is no sound, relay is defective. Relay plunger operating is not okay. Task 2. Check and overload protector. Step 1. Check continuity between 1 and 3. Step 2. If the continuity okay between 4 and 5, continuity of bimetal contacts okay. Step 3. If there is no continuity, overload is defective. Step 4. Check any rust formation in disc. If rust formation is there, not advisable to use. Task 3. Identification of compressor winding terminal pins with ohm meter or multimeter of fraction horsepower, pneumatic compression. Before carrying out the exercise, remember the following. Running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Resistance of run and starting winding sum of starting winding resistance and running winding resistance equal to common. Step 1. Set the multimeter in the resistance mode. Step 2. Measure the resistance between A and C, 20 ohms. Step 3. Record the value in the tabulation. Step 4. Measure the resistance between A and B, 40 ohms. Step 5. Record the value in the tabulation. Step 6. Measure the resistance between C and B, 60 ohms. Step 7. Record the value in the tabulation. Step 8. Identified A terminal pin become common terminal. Step 9. Identified B terminal pin become the starting winding. Step 10. Identified C terminal running winding. Resistance values slightly vary from manufacturer to manufacturer. Instructor must have compressor manufacturer specification. Task 4. Insulation testing in a compressor. Disconnect all wires connected to the compressor motor terminals. This includes power supply wires, control wires, and any other connections. Connect the leads of the megger to the terminals of the compressor motor. The megger typically has two leads, one for the positive terminal and one for the negative terminal. Ensure that the leads are securely connected and that there is no short circuit between them. Set the megger to the selected test voltage and initiate the test. The megger will apply the test voltage to the insulation system of the compressor motor and measure the insulation resistance. The test duration may vary depending on the specific requirements, but a typical duration is 1 minute. Once the test is complete, record the insulation resistance reading displayed on the megger. This reading indicates the resistance of the insulation system in ohms. A higher resistance value indicates better insulation integrity.
Task 5. Check the condition of a door switch. Step 1. Switch on the refrigerator. Step 2. Open the refrigerator door and check the condition of cabinet bulb. It should glow. Step 3. If it is not, check the bulb. Step 4. If the bulb is fused, replace the bulb in correct watts or normal requirement on refrigerator and check. Step 5. Still the bulb not glows, then switch off the refrigerator and remove the door switch and disconnect the wires. Step 6. Check the continuity in switch by multimeter or by test lamp is on and off position. Step 7. Check bulb holder wires. Step 8. If switch found defective, replace it and connect wires. Task 6. Check the condition of a thermostat. Step 1. Switch on the refrigerator. Step 2. If it is not run, check thermostat. Step 3. Remove the thermostat and its wires. Step 4. Test thermostat continuity in off and on position by multimeter or test lamp. Task 7. Check capacitor. Caution! Do not place fingers across the terminals of a capacitor. It may be charged and gives a shock. Short it with an insulated wire before handling. Step 1. Remove the capacitor for test. Step 2. Connect the capacitor in capacitor test circuit. Step 3. Check the fuse D in the circuit as shown. Step 4. Switch on the circuit plug E. Step 5. Press the charging switch B for 1 or 2 seconds. Step 6. Put off the circuit plug E. Step 7. With the switch open at B, touch the shorting switch C. If the capacitor is good, the switch will spark. Step 8. If it does not spark in the first time, try it 2 or 3 times before replacing the capacitor to the unit. Note: if the capacitor is good, it will spark. If the capacitor is shorted or grounded, the fuse D will blow as in the view. If the capacitor does not take a charge, it will not spark. This indicates an open circuit. The capacitor is connected to the terminals of the tester. Caution! The capacitor should be put in a protective case while testing it because a shorted capacitor may explode when put in a circuit.
Recap. In this video, we have discussed how to check and replace the electrical components of a refrigerator.